Welcome to Mathmastra. This is Saritha. Today we are going to discuss a topic of polynomials in the topic of algebra. Okay. So what is a polynomial? Polynomial is nothing but it is an algebraic expression. Yes, it is. It is also an algebraic expression, but it is in the form of a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 and so on. Yes, and this a naught should not be equal to 0 as well as a naught, a1, a2 and so on. These are all real constants. Any real constants. Okay, and this n we call it as a degree of that polynomial. Yes, this is the degree of that polynomial and this can be represented by p of x because this polynomial is in the variable x, that is why we represent with a p of x. So what is polynomial? It is an algebraic expression which is in the form of a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 and so on, and this a naught should not be equal to 0 and these are all the real constants, and this n is called the degree of an algebraic expression. What is the difference between the algebraic expression and polynomial? See, if you take an algebraic expression, we have considered all type of variables in one expression. See, sometimes 3x square y plus 3xyz plus 4y square. Yes, this is an algebraic expression. Now you observe there are a combination of variables. See, here x, y, z, three variables are there. But when you observe a polynomial, that polynomial should be in one variable only. So whether it should be in x variable or it can be in y variable or it can be z variable. Whatever may be the variable you take, but the entire expression must be in one variable only. Then only we can say that that expression, that algebraic expression is a polynomial. Yes, as means this polynomial is also a subcase of algebraic expression, isn't it? Means all polynomials are algebraic expressions. But when you converse the statement, all algebraic expressions need not be polynomials because some algebraic expressions may be in different variables, isn't it? That is why, so all polynomials are algebraic expressions, but all algebraic expressions need not be polynomials. Okay, some examples of polynomial. See, suppose I am considering a variable x. Yes, p of x is equal to 3x square plus 2x plus 4. Yes, it is a polynomial in variable x. So, polynomial in x. If you consider a variable as a y, what happens? 3y. Yes. Is it an algebraic expression? Yes, it is an algebraic expression. Is it a polynomial as well? Yes, it is polynomial as well because it is in only one variable, right? So that is why this is both the algebraic expression as well as the polynomial. This one is a polynomial as well as algebraic expression. But see, if you write 3xyz plus z square, is this a polynomial? No, right? This is not polynomial, but it is an algebraic expression. Okay, these are some different examples of a polynomial. Now, we will discuss different types of polynomial one by one. Okay. In types of polynomial, the first one is constant polynomial. What is a constant polynomial? A polynomial which has a degree is equal to 0, then that polynomial we call it as a constant polynomial. See, if you take p of x is equal to 2024. Yes. What is the degree of this polynomial? Yes, its degree is 0. A polynomial of degree 0 is called a constant polynomial. For example, p of x is equal to 2024. This can be written as 2024 into x power 0, isn't it? So what is the degree here? So degree is equal to 0, right? So that is why this is a constant polynomial. Okay. And our next one is linear polynomial. The second type is linear polynomial. What is a linear polynomial? A polynomial of degree is equal to 1 is called a linear polynomial. So the general form of a linear polynomial is always, so p of x, which is equal to ax plus b, where a should not be equal to 0. So this is a general form of a linear polynomial. So that must be p of x is equal to ax plus b form. Okay, and a should not be equal to 0. What happens if a is equal to 0? So if a is equal to 0, this entire term vanishes, ax term vanishes, right? So then you will be remain with the constant value. So what happens? The degree of constant value, the degree of a constant polynomial is always equal to 0. But what we have seen in the definition of a linear polynomial, the degree must be equal to 1, right? So that is why this constant, the coefficient of x, must not be equal to 0. Yes. For example, p of x is equal to 2x plus 1. Yes, this is a linear polynomial. And p of y is equal to 3y. Yes, it is a linear polynomial. So you can either have constant or not, but that a value should not be equal to 0. Yes, this is also a linear polynomial. This is also a linear polynomial, but this is in the variable x and this is in the variable y. Okay. And third type is quadratic polynomial. What is a quadratic polynomial? A polynomial of degree 2 is called a quadratic polynomial. And the general form of a quadratic polynomial is p of x is equal to ax square plus bx plus c, where a should not be equal to 0. Okay. So see, what is the degree of this polynomial? 2, right? 2 is the highest among all the terms. Yes, that is why the degree of this polynomial is 2. This is a quadratic polynomial. For example, this p of x can be 2x square plus 5x plus 6. Yes, is this a quadratic polynomial? Yes, it is a quadratic polynomial. P of y is equal to 3y square plus 2y. Is this a quadratic polynomial? Yes, this is a quadratic polynomial. B and C value can become 0, but A should not be equal to 0. Because if A is equal to 0, the degree of this polynomial changes. That is why it should not be equal to 0, but B and C value can be 0. See here, C is absent, although it is a quadratic polynomial, isn't it? See, if P of k means the variable k I am considering, what happens? 5k square. Is it a quadratic polynomial? Yes, it is a quadratic polynomial. But in this, B and C values are becoming 0. That is why we remain with only the first term 5k square. Although it is a quadratic polynomial. Yes. The fourth type is cubic polynomial. What is a cubic polynomial? A polynomial of degree 3 is called a cubic polynomial. So the general form of a cubic polynomial is p of x, which is equal to ax cube plus bx square plus cx plus d. Yes, and a should not be equal to 0. you should write this condition compulsory to all type of polynomial, because if you don't write this, and this a takes any type of value and it also takes the value of 0. Okay, that is why you should write this condition for every type of polynomial. Yes, this is the general form of a cubic polynomial, which is ax cube plus bx square plus cx plus d. Okay, and for example, p of x is equal to 3x cube plus 5x square plus 2. Yes, this is a cubic polynomial. This b, c, d value can become 0, but this a should not be equal to 0. Yes, so this is the example of a cubic polynomial. The last type is biquadratic polynomial. What is biquadratic polynomial? A polynomial which has degree equal to 4 then it is called a biquadratic polynomial. So the general form of a biquadratic polynomial is p of x is equal to ax to the power of 4 plus bx cube plus cx square plus dx plus e. Yes, this where an a should not be equal to 0. This is a general form of a biquadratic polynomial. Yes. So these are all different types of polynomials. Now we will define what is a 0 of a polynomial. Okay. So what is a 0 of a polynomial? Suppose if p of x is a polynomial. Yes. If p of x is a polynomial and k is any real constant. Okay. K is any real constant, and if this p of k is equal to 0, then we call that k as a 0 of a polynomial. Means we have one expression in p of x is equal to format. So in place of x, if we substitute the value of k, yes, k value is given. So we have to check whether this k is a 0 of a polynomial or not. So what we have to do? We have to substitute k in place of x. Then if you get the value of that entire expression is equal to 0, then automatically this k becomes a 0 of that polynomial. For example, if p of x is equal to x plus 2. Yes, this is a linear polynomial. Now, I am considering the k value as a minus 2. Okay, so the k can be any real value. I am considering k value as a minus 2. So what I have to do? I have to substitute in this polynomial and check whether it is a 0 of a polynomial or not. So what I am doing? I am substituting in place of x. So p of minus 2, which is equal to minus 2 plus 2. What happens? It will become 0. Yes, as the polynomial p of minus 2 is equal to 0, this minus 2 is called 0 of that polynomial. Okay. So this is how we can define 0 of a polynomial. Okay. Now you tell me, if I am considering a polynomial p of x is equal to 2024. Okay. So now you tell me what is the 0 of this polynomial. You can check with any value of k. So whether will it become 0 or not? Tell me. See, okay, I am taking the value of x as a 0. What happens? It is 2024 only. If I take x value as 1, we don't have any variable in this polynomial, isn't it? Even if you substitute any value of x, will it become 0? No, right? Because see, if you take x is equal to 0, what happens? As there is no x, the value remains same, which is 2024. It doesn't change. So if you substitute 1, 2, 3 and so on, no how, whatever number you take, it won't become 0. That is why, what is the 0 of a constant polynomial? We don't have any 0 of a constant polynomial. Means how many number of zeros are there for a constant polynomial, which is 0. Yes. Yes, this is a quadratic polynomial. So this can be factorized like x minus 2 into x minus 3. Okay, so this is p of x value. So what are the zeros of this polynomial? See, I am taking the value of k is equal to 2. What happens? Now I am substituting the value of 2 in place of x, which is 2 minus 2 and 2 minus 3. 2 minus 3. So it is becomes 0. So 2 is a 0 of that quadratic polynomial. And if I take the value of 3, k value as 3, what happens? It is 3 minus 2 and 3 minus 3. It also becomes 0. Means k is equal to 3 is also a 0 of that polynomial. Means the quadratic polynomial has here, in this case, it has two zeros. But sometimes it may have one zero also. Yes, that is why how many number of zeros for a quadratic polynomial, which is at most 2. Means it should not have more than two zeros. But at most two zeros are there for a quadratic polynomial. And we have one theorem, that is fundamental theorem of algebra. So what is that statement? If a polynomial of degree n has at most n zeros. Yes, what is the fundamental theorem of algebra? If a polynomial of degree n has at most n zeros, as this is a quadratic polynomial, it has at most how many zeros? Two zeros, right? As the degree of the quadratic polynomial is 2, so it has at most two zeros. So how many number of zeros are there for a cubic polynomial? See, as the degree of a cubic polynomial is 3, it has at most 3 zeros. Yes, and we have to check only for one thing, that is for constant polynomial, the number of zeros of that polynomial are 0. Okay, and for linear polynomial, as the degree of a linear polynomial is 1, it has at most 1 0. Means exactly 1 0 also you can say it has exactly 1 0. But when you come to quadratic, it has at most 2 zeros. For cubic, it has at most 3 zeros and so on. So according to the fundamental theorem of algebra. Okay. And if I take this p of x is equal to 0. This is a 0 polynomial. Okay. We call this polynomial as a 0. Yes. Now you tell me how many number of zeros are there for this polynomial. Now I am taking the value of x as a 1. What happens? This value doesn't change, right? Because it doesn't have any variable. So the value remains the same, which is equal to 0. And if you take 2 also, it will become 0. So if you so on, if you take any value, any real value, it always becoming 0. If a polynomial becomes 0, we can say that this number, this constant, real constant, is always a 0 of that polynomial. If we say like that, how many zeros are there for a 0 polynomial? There are infinite number of zeros are there for a 0 polynomial. See, even if you substitute any number, this value is always becoming 0. That is why, so the number of zeros are, how many number of zeros for a 0 polynomial? There are infinite number of zeros. Okay, these are some different types of polynomials. Thank you.